Okay, our next presenter, Brian spoke yesterday, but it's Brian Ruether who's a PhD student at Virginia Tech. So whenever you're ready, Brian.
Sure. Y'all see my PowerPoint?
Yes. Yeah, it's up.
Great. Okay. So yeah, hi everyone. Thanks for having me back for day two. Uh, I'm down at Virginia Tech under Dorothea Toll, and we're chemical ecology lab. So we're learning how to manage SLF in vineyards through the use of volatile plant-derived repellents, namely lavender oil, what I really want to talk about today. And also in the second half of the talk, I'm going to go over what we've collectively learned about SLF preference for different species and cultivars of grapevines, and then wrap up with where to go next. So a bit about life history and invasion history. I feel like I can skip that at this point in the talk, so I'll just give a brief background about SLF pressure in vineyards as well as plant-derived repellents. And some of this does overlap with my talk from yesterday, so I apologize if you've seen some of this twice now. But we've known for years now that large swaths of SLF will move into vineyards during late August and September, which has already been mentioned. And we also know that their movement in and out of vineyards fluctuates on a daily basis, meaning that populations will increase in vineyards during the peak of the day and then will dissipate again as it cools off, which suggests that SLF are using alternative host refuges like surrounding forests or farms or residential areas. But once they actually are in a vineyard, they'll feed a lot on shoots and they'll produce lots of honeydew and they will move down the plant as phloem sap production lessens post-harvest. And this really rather vigorous feeding is, or during one season, affects grape production for the next season, meaning SLF reduce winter hardiness in the plants, which can cause severe losses in yield, especially in eastern Pennsylvania. So now how do we deal with these vineyard pests, right? So classical insecticides are effective at knocking down these populations within a vineyard, but they don't necessarily prevent the initial infestation or recolonization from those outside reservoirs. So volatile plant specialized metabolism derived repellents may actually prevent or reduce initial or that recurring infestation. They might prevent or reduce harm to growers and beneficial arthropods, and they might allow growers to spend less on traditional insecticides overall. So just a bit about what plant specialized metabolites are and why we should care about them for managing SLF. Primary metabolites aid to, or they're for anything to do with direct growth in the plant, while specialized metabolites deal with everything else the plant needs. So things like defense and hormone production, other things like that. And so out of those, terpenoids are classic chemicals that are often employed for defense because they can act as repellents and as feeding deterrents to a wide variety of different pest species, with a lot of examples of repellency toward hemipterans. And so many of the smells you're likely familiar with are due to terpenoids like linalool and lavender, or things in like the rose family, alpha pinene and pine or mint, and alpha humulene is another example, and things like ginger or hops. And because these compounds are hydrophobic, they often come together with other hydrophobic metabolites to form what we know commonly as essential oils. And so then how do we know which volatiles will work against SLF, and how can we apply them so that we don't damage the host plant in the process, right? So something to consider is that a lot of these compounds are compartmentalized in the plant and can cause phytotoxicity when they're exposed to the wrong part or if they're too highly concentrated. So moving on, when first getting into this work in 2020, we only really knew of this one 2011 study based in South Korea, where researchers like us were sort of scrambling to learn more about SLF. And this group wanted to test a variety of essential oils in a sort of screening process. And out of 10 different ones, they found that lavender essential oil had an effect. And they specifically found that linalool, the monoterpene alcohol that I just mentioned, elicited an electrochemical response in all life stages via SLF antennae, and that was tested using gas chromatography coupled with an electroantennogram detector. And they also found that the oil was avoided in Y-tube olfactometer assays, field assays, and these results also varied by life stage and the dosage. And so for the first part of the talk, I'll be comparing their results and methodologies with ours so we can all better understand the state of this field. And so our lab assays consisted of a screen process as well. We used 6 oils which previously showed repellency against other hemipterans, while also avoiding the ones that Yoon and others determined were not very effective. And so our lab, we repeated our assays using cuttings of Tree of Heaven and grapes. We used Chardonnay for those. And so we would treat 1/2 of the dish with one of 3 different dilutions of repellent and hexane, and then place 10-second instar nymphs in the middle of these dishes, and then track the movement over a 24-hour period. And then from that data, we created a repellency index, and that's where values closer to +10 indicate a stronger avoidance effect, and then values closer to -10 would indicate a stronger attractant effect. And so from these tests, we learned that lavender oil was in the top 3 of the 6 oils that we tested in terms of avoidance. And here we're looking at how 3 concentrations of lavender oil diluted into hexane affected our 10 nymphs over time. So again, more positive values will indicate a stronger repellent effect. So all 3 concentrations start off here working very similarly, but some variation shows up after the 2-hour mark. And so we can see that the more concentrated solutions are more effective later, while the 1/1000 dilution, 1/1000 dilution's efficacy seems to sort of drop off here after 4 hours. And to the side here, I've also provided the volumes for comparison later, because that's what you and colleagues do. And we additionally noted that high mortality caused by our 1/10 dilution of lavender oil is right here. It's really interesting. And that indicated to us that there's either some toxicity with the volatile or the tactile effect. Beyond that, if we compare, those results with what you and colleagues did, things actually line up fairly well. While they used more life stages for their lab assays than we did, we both ended up seeing higher volumes of lavender oil being more effective. In their Y-tube assays, all the life stages chose against the 10 microliters of lavender oil, sort of similar to how our nymphs chose against the about 30 microliter for the 1/10 dilution of lavender oil. We also found that at a very low dose, the 0.28 microliter or the 1/1000 dilution didn't even last after 2 hours, even in that enclosed environment of a petri dish. And so one last thing I want to note here is there's 2 points that had already popped up. So their study observed a response after 5 minutes, and that was just one choice. It was final, while we allowed our nymphs to make multiple choices. So I just want to point out the contexts are quite different. So after that, our lab assays, we moved on to semi-field assays in 2021 and 22. So these were retention studies that used a mark release recapture method to quantify repellency. And we did that in an infested site in Winchester, Virginia. We used potted Riesling grapevines, also a wine grape, Vitis vinifera, and they were covered by shade tents provided by our collaborators at the USDA. And so we wanted to slowly release our compounds of interest over time. And to do that, we separately mixed the top 3 compounds, which included lavender, from our lab assays into splat, which is a release matrix more typically used for pheromone and attractant release, but it works well with hydrophobic compounds in general. So we applied these compounds as separate treatments at 2 different points on our grapevines, on the bottom of the trunk and on the top. And once our treatments were affixed, we applied 15 wild-caught SLF adults marked with one of 4 fluorescent powders onto the host plant, and then just noted their retention over a 24-hour period. And so for our results, we plotted the mean percentage retention of SLF against treatment at each of our time points up to 24 hours. And we ran separate one-way ANOVAs, and they showed that while we saw trends with these compounds, especially with lavender, the third one from the left, compared to this flat-based control for these white bars, there were no significant differences present. I just want to point out the biggest issue with these retention studies was getting the adults to stay on the young grapevines. So you can see that for the top here at best, really only 20% would remain even on the control plants. And so we figured that this was the case due to less phloem production in these younger plants than in older vines where the adults will swarm, and probably due to the presence of other host plants in the surrounding area, like wild grapevines and tree of heaven, which may have been just more attractive. And so based off of these results, we thought we would take lavender oil and this other compound here, CNR1, compound mixture CNR1, into a vineyard context to see how these compounds would work with SLF in a different context, right? So one that didn't artificially place insects on the host plant. So in September of last year, we conducted studies in an environmental vineyard, or an experimental vineyard rather, owned by the Rutgers AREC in South Jersey. And for these assays, we've worked with two varieties of wine grapes, so a block of Traminette and a block of Syrah or Shiraz. And my research assistant and I first counted the number of bugs in a 1 meter radius around each vine's canopy, and that was just looking at the center vine out of each 5 vine panel. And then we affixed 4 cards containing 1 of 4 treatments to each vine, and we placed these cards in the canopy depending on where the SLF density was the most intense, according to our pre-treatment counts. And so then we spread out our treatments using a randomized block design with 4 experimental replicates per grape variety. And so to get our response variable, my assistant and I then counted the number of bugs after treatment application at these different time points. And so our first experiment ran during the second week of September, where the average high temp was fairly warm. And after hours of treatment, this is what, or at 4 hours of treatment rather, this is what we got. So our y-axis measures the difference between the count of insects pre-treatment compared to post-treatment, and our x-axis shows the different treatments. And so I should also note that these are combined data from both varieties here, so it equals 8, as variety did not have an effect on our model at any point. And so while counts for CNR1 and UTC treatments were statistically similar, there is strong support that lavender and splat treatments were significantly different from one another. And this was odd to us because we'd never seen an attraction to splat in the lab or in the field before, nor had we seen anything indicating this attraction from the literature for other insects. And besides that, despite not observing strong evidence that lavender is causing significant repellency compared to our untreated control, we still see that this trend is this trend with lavender is quite low compared to the other treatments. And so if we move on to 24 hours, we move on to 24 hours, we see that these effects become less pronounced with only marginal support for the effects of these treatments. And this is the trend that we continue to see the remainder of the study up until we stopped at 52 hours. But with more time available to us in the field, we wanted to see if we could extend the repellency of lavender oil by just doubling the dose. And so our second experiment ran during the last week of September, where the average temperature was about 66 degrees Fahrenheit, quite a bit colder. And our results did not turn out like we had hypothesized. And so at 4 hours post-treatment, none of the treatments significantly affected our SLF counts. And although counts for CNR1 and lavender are below the overall mean, there's really only weak support for any of these treatments affecting SLF numbers. And if we fast forward to 24 hours, we see the same trend in the first week occurring here and continuing on to 52 hours. So Yoon and colleagues also did a field study, and their results were more effective than ours. So I wanted to highlight some comparisons and contrast here as well. And so I pictured here what they use, which are silicone sleeve septa, and a cartoon version of what we use, which is splat. And so while they conducted their studies in forested areas using sticky bands on adult tree of heaven, we used a marked release capture method with potted plants, which were arguably less of an attractive stimulant compared to adult trees, at least in our semi-field assays. We also had different dose-dependent effects, likely affected by these different release methods. So when Yoon and colleagues released 10, 20, and 30 microliters of lavender oil from silicone septa, all three of these concentrations actually induced significant repellency to adults and fourth instar nymphs. However, we saw that our concentrations much, much higher, 250 microliter dosages via splat only caused weak repellency in the semi-field assays, and that our 4 milliliter dosages via splat caused significant, albeit very short, lasting effects in the vineyard. And so it's clear to us that the method of release is really a critical component to working in the system. So now I want to switch gears a bit and then sort of tie all of this back together at the end. So let's talk a little bit more about how SLF feed on different grapevine cultivars and species and what that could mean for their management. So in 2020, Heather and Ashley Leach conducted some experiments to understand how SLF behavior and phenology coincide with the host phenology of grapevines. And they conducted their work in a number of different vineyards, but they noted that all these vineyards were growing grapes that had the same species of grapevine except for one hybrid, and that SLF seemed to develop and behave similarly across all of these different sites. And so at this point in 2020, there's no evidence that cultivar mattered, but the question was still on a lot of people's radar. And so moving forward onto 2022 and 23, both Nixon and colleagues and Elsenson and colleagues published work showing that muscadine grapes were not able to support SLF to adulthood alone. And so Nixon's group additionally showed that SLF would feed on frost grapes, so the Vitis riparia, but they did not serve to increase survivorship or decrease development time when paired with Tree of Heaven. That's really important to know for rearing. And we also see with Elsenson's group that SLF could survive to adulthood on a diet of Vitis vinifera Riesling alone or paired with Tree of Heaven. And so that's also really important to know for rearing and also for management practices. So these two studies really are incredibly important for understanding management of our vineyards in the future. And I know a lot of studies now are basing their work off of these two and off of Leach and Leach, and including my own. And so when we were conducting our second set of experiments in the vineyard, we noticed a trend of more insects on Traminette than on Syrah, both of which are wine grapes, Vitis vinifera, and Traminette being a hybrid. We also calculated strong support for this phenomenon existing 24 hours post-treatment with weak to no support for this difference at other time points. And so it seems to persist. And from my study also, these differences in variety could be due to what looked like Syrah senescent earlier in the season than Traminette, leading SLF to settle on the variety with more phloem production. And this was just indicated to us by more chlorophyll present in the leaves later on in the season. And so all these studies looking at SLF preference for different types of grapes lead us to more questions that I think we really ought to keep in mind moving forward. And so besides just phenological differences, are there any volatiles present in wine grapes that make them more attractive to SLF over other grapes? And based off of that, can linalool oil disrupt that attraction? And so the same question could also be asked for different cultivars of wine grapes as well. Another question would be expanding on the observation from my own vineyard studies. Does grapevine phenology differ across cultivars? And if so, this could be really important for implementing management tactics on different cultivars at different points of the year. And finally, could planting lavender fields around vineyards actually aid in pest management? This is sort of a fantastical idea, but I would personally love to see if this would actually work. So at this point, we can't really recommend a release method for lavender oil, but it does look like it could be effective with the right setup. And so we'd like to test the effective range of lavender oil to affect SLF behavior by both dose and especially by release method. So some other options besides splat could be using a plastic pouch like this one or silicone. But just keep in mind that both of these types of release methods will be temperature dependent, which could be an issue in September and October. And so alternatives could be using a method like auto dissemination, in which particles infused with a compound of interest are spread throughout an area by adhering to the cuticle of the insect. So essentially, SLF would be doing the work of spreading the compounds for us. It's been used with pheromone work before. And finally, this was brought up to me yesterday by Pira. Automatic misting devices could be used to get around the temperature dependency of things like splat or plastic release devices. And so on top is a schematic from Michigan State University's microsprayer, and then down below is a device from Sutera. And so I really hope I can facilitate some discussion from this talk. I'm really happy to have been invited. And so I'll take any questions. But first, I would really like to acknowledge that this research is funded by the USDA SCRI grant. I'd like to thank my advisor, Dr. Toll, and the Toll Lab as a whole, our collaborators at Rutgers and at the USDA, my undergraduate assistants, my committee members at Virginia Tech, and then our departments supported me, as well as the AT-TPSC program, and also ArborJet and Iskatech for contributing CNR1 and SPLAT, respectively. So yeah, thanks for being here. Thanks for listening to my talk.
All right, thanks, Brian.
Mm-hmm.
Yeah, see, there's one question in the Q&A that I don't know if you would have an idea of this, but do you know what the cost of the lavender oil treatment could be?
That would take
It's
some
probably
thinking.
yeah, probably gonna depend on a lot of things like what you mentioned as far as how to deploy it and how much.
Exactly. Yeah. So, I mean, the raw price of lavender oil would be part of it, but also how much it would take to formulate something like a release device. And it can be expensive depending on the purity. But I guess if all you're really after is the linalool oil content, that might be able to improve your buying options.
Okay. Yeah, and I'll ask you if you just keep an eye. Oh, there's another one just came up saying that they know that there's lavender. Lavender affects other insects, for example. It can be used as an ant repellent. So how would using lavender to repel SLF affect other insects?
Yeah, I mean, if you look at the literature, lavender seems to be pretty beneficial for human interests. So it tends to attract quite a lot of pollinators. It's linalool, at least, is present in a lot of nectars, especially like I mentioned in the Lamiaceae family and the rose family. And so it tends to attract more beneficial arthropods, whereas it repels others, like I think some other pest nectarines in addition to SLF. Of course, this would have to be more rigorously tested. I think it would be cool to do sort of a multi-insect study using lavender oil, but yeah, that's all I have to say about that.
All right. Thanks, Brian. Yeah, and like I said,
Yeah.
if you just would keep an eye on that in case some more come up, if you would answer those, please.
Yep.
Thank you.